Hello viewers, we are going to be looking at permutation, and under permutation we are going to consider these two problems. Now, permutation is used in mathematics when the arrangement of objects or numbers etc. Are to be considered. For instance, if you have 1, 2, 3, 4, 5, you look at the different ways in which the numbers I've just mentioned 1, 2, 3, 5 can be arranged. And so if you're looking at that, if you're considering that, it means you're actually doing a permutation. So let's solve this example. Okay, we are asked to find 8, 10 permutation 8 and 5 permutation 2. So we have the solution. And the general formula for permutation for n permutation r is equal to n factorial all over n minus r factorial. So from our example 1, question 1 rather, we are asked to find 10 permutation 8. So from the arrangement, our n is equal to 10, our r is equal to 8. And so our 10 permutation 8 will be equal to, we have 10 factorial all over n here is 10 minus 8 or bracket factorial. So this is how to express 10 factorial. 10 factorial is the same thing as in 10 times 9 times 8 times 7 times 6 times, okay, let's say 10 permutation 2, let's use 2 to make it easy for us, times 6 times 5 times, okay, let me erase it and do it properly. So I said that 10 permutation 8, 10 permutation, okay, we are using 2 here, yeah. So it's the same thing, permutation 2, the same thing as saying 10 factorial from this formula all over 10, which is n minus 2 factorial. And then I said 10 factorial is the same thing as saying 10 times 9 times 8 times 7 times 6 times 5 times 4 times 2 times 1 divided by 10 minus 2 will be 8 factorial. Okay, I think this is what I should have done first. Let me erase it and do it that way. So 10 factorial, this will be 10 factorial all over 10 minus 2 will give us 8 factorial. So this will be equal to, let's take the 10 factorial, 10 times 9 times 8 times 7 times 6 and 5 times 4 times 3 times 2 times 1 all over 8 factorial is the same thing as saying 8 times 7, 6 times 5 times 4, 8 times 2 times 1. So from here we can cancel out and then find what our value of 10 permutation 2 will be. And so this is 8, this can cancel out 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1. And so we are left with 10 times 9, which is equal to 90. However, since we have 10 factorial here divided by 8 factorial, you can also express this as 10 times 9 times 8 factorial, since we have 8 factorial here all over 8 factorial. When you cancel out the 8 factorial, you still have this. So that's another convenient way of solving that question. So you can do this or you take this other route. So let's solve 5 combination permutation 2. So our II 5 permutation 2 will be equal to, from this formula, 5 factorial all over 5 minus 2 factorial. So our II is 5 permutation 2. So this will be 5 factorial all over 5 minus 2 factorial. So this is the same thing as saying 5 times, okay, this will be 5 factorial divided by 5 minus 2 will give us 3 factorial. So this is the same thing as saying 5 times 5 times. Since we have 3 factorial in the denominator, we can say 3 factorial divided by 3 factorial. So this 3 factorial will cancel out. And so our answer becomes 20. So now what we're having here is that 5 permutation 2 equal to 20. So what this implies is this permutation can actually be arranged in 20 ways, while this other one can be arranged in 90 ways.